Hi, JP. So you sent me 15 questions, all 15 questions in a span of 3 minutes on the binomial probability homework. And rather than go through and answer every single question, I'm just going to give you a big review of binomial probabilities. It's the same things that you saw in the videos, but just in a more condensed format. So basically, when we have binomial probabilities, they are probabilities of experiments where there's a fixed number of trials and there are two outcomes. One is a success, one is a failure. There's a probability of P that is the same for every trial to have a success, and then each of the trials are independent. If those four characteristics apply, then you can use the binomial probability functions in your calculator. So what you want to do is, out of the trials, you want to know what is the probability of a certain number of successes. So if you want a specific number of successes out of all the trials, or an exact number of successes out of all the trials, that's when you use Binomcdf. So write I guess it doesn't. So I'll just highlight right here. So that. So, and you can get to there by going to second vars and then choose Binomcdf. Then you will be asked to put in an N, a P, and an X. Again, N is the number of trials, P is the probability of a success, and X is the exact number of successes that you're trying to find the probability of. So, looking at the example here, at FCC, 60% of students take statistics as their math requirement. If 18 students are sampled, what is the probability that 7 of them take statistics as their math requirement? So in this case, there are 18 sampled. That's a fixed number of trials, 18. Probability of a success is 60% or 0.60, and that's the same for every student, or every trial rather. And then the number of the exact number of successes that we're trying to find the probability of is 7. So you would do binom, and that should say PDF. So second var is Binomcdf, and then you would put in 18 for N, 0.60 for P, and 7 for X. And so in some of the homework questions, they actually give you the N, the P, and the X. You just plug them into the calculator, into Binomcdf. So you use PDF if it is an exact number of successes. If you have probabilities that are cumulative, meaning you would have to add some probabilities together, you're going to use Binomcdf instead. Now, I've got this broken down into 4 categories. So Binomcdf NPX, Binomcdf NPX minus 1, 1 minus Binomcdf NPX, and 1 minus Binomcdf NPX minus 1. Now, in this case, the X is in the question when they say what's the probability of no more than 5, 5 would be the X. So I broke this down into categories, and this is when you would use each one of these. So if we said no more than X or at most X, you just put in NP and whatever that number is. So if they said no more than 3, you'd put 3 in for X. If they said less than or fewer than X, so let's say less than 3, fewer than 3, you would put in 3 minus 1, so you would put in 2 instead, so for that third number. If they said greater than or more than a number, so greater than or more than, say, 5, you would do 1 minus Binomcdf NP, and then you'd put in 5, or whatever the X is in that case. And then if it's at least X or no less than X, whatever that X is, you would do 1 minus Binomcdf NP, and then that X minus 1. So if they said at least 5, you'd say 1 minus Binomcdf NP 4. And again, this is review, which is why I'm kind of going quickly through it. So here we have the same scenario. At FCC, 60% of students take statistics as their math requirement. If 18 students are sampled, find the probability that at least 12 take statistics. So going back and looking at our little cheat sheet, at least is the bottom right here. At least X. So in this case, we were doing at least 12. So we know we're going to do 1 minus Binomcdf NP and then 12 minus 1, which would be 11. So you'll see here I have 1 minus Binomcdf 18 because that's the number of trials, 0.60 is the probability, and then x minus 1 would be 11. 12 minus 1 is 11. Find the probability of less than 5 when we have less than. It's right there. You do NP x minus 1. So Binomcdf, N is 18, P is 60, x minus 1 is 4. 5 minus 1 is 4. And then you would put that in the calculator and get your answer. Find the probability of no more than 16. So looking at the cheat sheet again, no more than, right here, is just regular N, P, and X. So we have no more than 16. So we actually get to put in 16 this time. Find the probability that greater than 9 takes statistics. So greater than, you're going to do 1 minus Binomcdf NPX. So this would be 1 minus Binomcdf N, 18.60 is your P, X is 9. Okay, so if you follow this little cheat sheet, you should be able to do the whole set of homework. Then the only other thing in Chapter 5, binomials, is the mean and the standard deviation of a binomial random variable. So you can still do var stats, L1, L2, but that would require you to create a table first. If you recognize that it's a binomial random variable and you want to find the mean or standard deviation, and expected value, if you will recall, is another name for the mean. It is the formula N times P for the mean. So N being the number of trials, P being the probability. Standard deviation is NPQ, square root of NPQ rather, and N is the number of trials, P is the probability of success, Q is 1 minus P. So once you know P, you can find Q. So if you look at this last example, at FCC, 60% of students take statistics. If you sample 18 students, how many would you expect to take stats? Then find the standard deviation of the binomial random variable. So how many would you expect? You're going to find what's called the expected value, which is the same as the mean, which is N times P. So N, we said, was 18. P is 0.60. Multiply these two together, you get 10.8. Then it said find the standard deviation of the binomial random variable. So standard deviation is square root of NPQ. N is 18. P is 0.60. That means Q is 0.40 because Q is 1 minus P, which is 0.40. So you'll see I plugged it in here. Square root of 18 times 0.60 times 0.40 is 2.8. So that is my crash course on binomials. Good luck.